Hi, and welcome to today's session on sequences and patterns. So, we see sequences and patterns actually in everyday life. I mean, just a few examples of these. Every time that we're parked up at traffic lights, the traffic lights change in a certain sequence. Other sequences that are read there are even in things like music, where the bassist or the drummist or the lead guitarist, they'll be strumming their instruments or beating the drums in a certain rhythm, and that will also be in the sequence. Sequences are absolutely everywhere, even in computer games. But number patterns, those are how you can try and move from maybe one number in your pattern to the next number or another number in the pattern. And by using that information, you're actually able to predict what the next outcome might be. Anytime that we're dealing with sequences, they are just a number of patterns, but they're going to follow a certain rule. In which case we'll be looking at those in a different video. So we've got certain patterns which can be what we call infinite, in which case they have a start and they never ever end, in which case they go on forever and ever and ever and ever. They may not have a start, they may go on forever and ever the other way as well. And we've also got the opposite to that, which is the finite. So there is only a certain amount of numbers within the pattern. It has a start, it has a finish, it has a beginning, it has an end. We can, just as we was talking about with patterns, we can actually describe how to get from one term to another. So here I've got a sequence where I've got 2, 5, 8, 11, 14, and this is an infinite because it continues. That's what these three dots just here mean. And each one of these is a term. This is my first term, my second term, my third term, my fourth term, my fifth term, and then going on forever. So I can describe how I can get from the one to the next just by looking at how do I get from 2 to 5? How do I get from 5 to 8? How do I get from 8 to 11? How do I get from 11 to 14? Some of you may have already spotted that each time that you're moving from the one number to the next, you are adding 3. In which case we describe this as plus 3. By using this information, we can actually find missing numbers that we've got within our pattern or sequence. So here I've got a pattern which goes 32, 28, 24. I've got 2 missing ones, and then 12 and 8. But as some of you may already be able to identify, this is actually going down in 4s constantly, which is proved by the last 2 numbers. So my missing numbers for this would be 20 and 16. So these are just filling. And like we just said, we're describing this as -4. Each term to get to the next one, I'm taking 4 away. So a couple of different sequences that we could do with knowing, or at least be made aware of. Here I've got 1, 3, 6, 10, and 15. These are my triangle numbers. Some of you may recognise these type of setups. And these ones from maybe if you play pool or if you play snooker. Here we've got 1, 4, 9, 16, and 25. And as some of you may be able to tell from the pictures, these are our square numbers. These ones especially we might be using if we're doing a quadratic nth term. And here I've got a sequence of 1, 1, 2, 3, 5, 8, 13, 21, and 34. And this is the Fibonacci sequence. Now, it's Fibonacci because if you take each of the first terms, it actually adds up to give us our next term in our sequence. So here I've got nothing beforehand, so nothing add 1 gives me 1. 1 add 1 gives me 2. 2 add 1 gives me 3, and so on and so forth. So if you like what you see, please subscribe. Thank you very much for watching.